back to the second one of our calculus rules, our differentiation rules. Last tutorial we looked at the chain rule. Today we're going to look at what's called the product rule. Now, very similar to the chain rule, these types of functions you will have seen before, but we need a special technique to differentiate these functions. Now, the types of functions we're looking at are called product functions, but they're no different to functions that you've seen before. An example that's beyond our capabilities at this point of the course to differentiate would be something like x plus 2, lots of sine x squared plus 5. So you've got two separate functions. Now, algebraically, we don't have a multiplication in between those two, but we're obviously multiplying this first part by this second part. If we're looking at two separate functions that are multiplied together and we don't want to expand, and there'll be times where we don't want to expand, it's not a good use of our time, we get to do something similar to the chain rule, which is to define two separate parts of the function. Okay, this time we're using the letters u and v to denote the two parts that are multiplied together. So in this example here, we won't complete this one, the first part x plus 2 is going to be u, and the second part sine x squared plus 5 is going to be v. If that's the case, and u and v are our two parts of that equation, then we can have a function, a product rule that says dy dx equals u times dv dx, then switch them around and add v times du dx. So there's a nice symmetry here. You've got u dv dx and v du dx. Now this product rule is one of the formulas on your methods exam sheet at the end of the year, but it's also one you'll be very familiar with by the end of the course. Just a quick note here, and it touches on this particular example here, quite often we may need the chain rule as well as the product rule. So if you were to complete this particular example here, you'd have the product rule with this first part times the second part, but then this part here, the sine x squared plus 5, this sets up as a composite function. So we have sine lots of x squared plus 5, and you would have to differentiate this one separately. So you take this sine x squared plus 5, differentiate it separately using the chain rule, and then bring it back together with the product rule. But in this tutorial, we'll just touch on the basics of the product rule and the application to an example that you could actually do by expanding. So example here is going to be two brackets, and again I'll let you decide whether it's time efficient to use the product rule here or whether you choose to actually expand these brackets. And again, that's an activity I want you to do to check our final solution. We've got 2x plus 3 as one function, and we're going to multiply this by a second function. Also a polynomial, 2x squared minus 5x. So our steps, and I've got a 6-step process here that we're going to follow through for all of these cases. We're going to define u and v. And again, I've colour-coded it for you. So the first part here, u is going to be 2x plus 3. Our second part, v, is going to be 2x squared minus 5x. We keep them separate, we define what they are, and then we're at our second step, which is basically to differentiate each of those parts separately. So here we're going to need dv dx, and we're also going to need du dx. So our working out follows down the page here. If we differentiate u with respect to x, well, 2x is the only part that's left, and that gives us 2, and 3 as a constant will disappear. If we differentiate v, we have 2x squared minus 5x, power comes out the front and multiplies by the coefficient to give you 4x, and 5x to the power of 1 just drops down and leaves you as a coefficient of minus 5. So there are two parts, and these four parts here are going to be used in the rule. So if you've got a nice clear setup, you'll identify the four parts that you have, and you're actually following some sort of cross-multiplication process, where you're going to have u times dv dx, so u times dv dx, they will multiply together, and v times du dx. So your setouts important here, as is your definitions of u and v, and you'll be able to cross-multiply and get a nice technique going very quickly. So what we've got here to start with is we're going to write down our formula in full to practice the formula. dy dx equals u times dv dx plus v times du dx. Okay, step 4, we've already got our parts ready to go. We've got this ready, prepared to substitute in. dy dx equals, again colour-coded, you can see there, 2x plus 3, brackets 4x minus 5. That's these parts cross-multiplied, the addition sign, and we're going to cross-multiply these parts here. So 2x squared minus 5x times 2, just kept the parts in a bracket. At this stage, that's all I want. I want to be able to come back and check my working, and I've got those parts ready to go. Step 5 is obviously a simplification process. We're going to have some like terms here. I've expanded the brackets, brought this coefficient to the front, and done a little bit of tidying up, and we end up with 12x squared minus 8x minus 15. A couple of quick methods to cross-check. Again, if your working is nice and neat, you'll be able to cross-check through your actual process. But just having a quick look at the expansion here, I'm not going to expand all the terms, but just to get an idea, this, when expanded, would have been a cubic, the highest power there being 4x cubed from these first two terms multiplied together, if I differentiate 4x cubed, I should end up down at 12x squared. So that part looks right. And the coefficient at the end there, sorry, the constant at the end there, minus 15, would need to come from an x term here. And we've got 3 lots of minus 5x. So the last term there is minus 15x. Differentiate minus 15x. I'm left with minus 15. So it's looking right. I need to do the full expansion to check the minus 8x, but at least I've got some sort of cross-checking process going, and I'd be reasonably confident with that as an answer. I'm on to the next question. Okay, next tutorial we'll move on to the quotient rule, which will be a similar technique, defining our variables and going through a stepping process to actually get our final answer. Okay, thank you.